when we ask for your exact values, it means you're not going to pick up your calculator. You're going to find where the quadrant is, you're going to draw the triangle, and you're going to use your special triangle. When we do that, it doesn't matter to me which triangle you use, whether it has a radius of 2, of 10, of 1, that doesn't matter, whichever one you're familiar with. So we also talked about how do I find these in radians. So if I took a 60-degree angle and I wanted to convert this to radians, I would say times pi over 180. So essentially, I'm taking 60 into 180, right? 3 times. If I do a 45-degree angle, I'm taking 45 into 180, 4 times. If I do a 30-degree angle, I'm taking 30 into 180, 6 times. So we see a pattern here. When we take our special angle, we only have 3 of them that we're using, 30, 60, and 45, and we divide them into 180. That becomes your bottom number. Now, an easy way to locate these is this. If this is my circle, we always open up standard position. My angles open up this way, counterclockwise. They start here, they open up. This we call a terminal end, when it stops right there. This is the terminal side. So say, for instance, this angle is 30 degrees. We know we can drop a triangle. We know, therefore, and no matter what triangle you're on, if you like to do it this way, 1, and then this is your 2, whatever kind of circle you want to put this on. This is your radical 3. We said if we do this information here, we can do all your trig functions from that. We make trig ratios. We could do your sine, y over r, 1 over 2. We could do your cosine, x over r, and your tangent, if you remember, is y over x. And the nice part about this now, we don't have to rationalize any denominators. To find your reciprocals, this is what you guys missed. I'm just kind of recapping a little bit. To do your reciprocals, we said tangent is a reciprocal with cotangent. They have different letters. We're just going to take this, flip it over. Radical 3 over 1, and we're going to leave it as radical 3. So this guy needs a different letter. The S needs to now be a C, cosecant. And that's r over y, but all we got to do is flip this guy over. 2 over 1 or 2. A cosine becomes a secant. R over x, we just got to take this, flip it over. So once we found our 3 basic ones, we can find any of the other ones. Now, we had a little unique situation. I'll get to this guy. We said, where do we find 5 pi over 6? First of all, 6 goes into 180 how many times? 30. So we've got a 30-degree special triangle, which is one that I just drew right here. So we can reflect this guy to show another quadrant. So we reflected it into this quadrant. We reflected it into this quadrant. We reflected it into this quadrant. It's going to have all these numbers, but it's going to be a positive and negative depending on, is x negative, is x positive, is y positive, is y negative. Now, an easy way to read these in radians is we took your bottom number. This was 0. This is pi, 180. So we said, okay, take the bottom number, make it like this. Pi over 6. To cancel out to be pi, what number do I need in my numerator? 6. So I want to put the same top and bottom. Over here, this is my 2 pi. I doubled it. 12 pi over 6. So now, as I come around, I come around here and I stop short. I want 5 pi. It's 1 short of 6 pi. This is my 5 pi over 6. From here to here, I stop short of 6. So I'm 5 pi over 6. I have the same reference angle, the same sides. However, I noticed x over here is positive or negative. My axis, is this a positive or negative x? Negative. Is this a positive or negative y? And we said your radius is always positive because it measures a distance. So now when I find these, the only thing that's going to change is anything that has an x in here, this is now going to become negative. And this I'm just going to say 5 pi over 6. And my tangent, negative. My cosecant stays okay, but my secant and my cotangent change. So depending on what quadrant we terminate in, okay, we're going to use the same setup, but we're going to make this little information box, and we never have to go back and see where is cosine positive, where is sine positive, where is tangent positive. This will tell us. If we're looking for an angle 7 pi over 6, what quadrant would 7 pi over 6 be in? 3. It's coming around. There's my 6. Whoops, one more. There's my 7 pi. What's going to change for my information here? Is my x still negative? How about my y in quadrant 3? Is my y positive or negative? Negative. And my radius stays the same. So now I also have my sine negative, my cosecant negative. But a negative divided by a negative now will give me a positive tangent. Right? A negative divided by a negative will give me a positive. So we watched our angles rotate around this circle. Okay?
What number is it?
No, these are the ones I kind of gave you for homework, but I was just kind of giving you a recap of what we did, of where we got those angles from. So we start with your base angles and we kind of rotate them around your circle counterclockwise. Remember, we do counterclockwise. Any negative goes clockwise. Okay, so far? All right, let's try the next one. 2 pi over 3. So, how many times does 3 go into 180? 60. So, again, I have my 60-degree triangle, my 30, 60, 90. But 60 is going to be my reference angle. So I take the 3, and what do I put on top? What number? So that it cancels out to pi. I want to be able to cancel this out, so this is pi. 3. And over here I want 2 pi, so I double it. So I start here, I come around, I need to get to 2 pi. I come past here, that's 3 pi. So 2 pi is in this quadrant. So this is 2 pi over 3, which is, watch, 3 goes into 180, 60 times. What is 60 times 2? 120. And isn't that what gives me a 60-degree angle right down here? Easier way than doing your formulas. Now, we remembered our 60. Opposite our 30 is 1. Opposite our 60 is radical 3. Radius 2. I think most of you remembered it this way. So, pull this out. This is why your x and y axis are sitting right there. In this quadrant, what is x? Positive or negative? Negative. In this quadrant, is y positive or negative? Y is positive. And r, always positive. So from here, can we do all of your functions? Sine of 2 pi over 3. Y over r. I've got it all right here. I never have to look back. Radical 3 over 2. The cosine of 2 pi over 3 x over r, negative 1 over 2. The tangent of 2 pi over 3, y over x, y over x, radical 3 over negative 1, or negative radical 3. Can I do all my reciprocals right off of this? I never have to look back again. Cosecant of 2 pi over 3, take this guy and flip it over. 2 over radical 3. Secant of 2 pi over 3, negative 2 over 1, or just negative 2. And cotangent of 2 pi over 3, now I have to put that 1 back there, negative 1 over radical 3. Does this make sense? Tell me if it doesn't. Everybody's able to do this. You can figure out what special triangle you need. Jeremiah.
On the last one, the x was radical 3. When you can change the x and y.
You're right, because the last one had a 30-degree reference angle. So say I put my triangle over here. This guy was a 30-degree triangle. This one was a 60 here, so 60 was up here. Opposite the 30 is always 1. Opposite the 60 is always radical 3. So in this case, you're right. The x was radical 3 because it was opposite the 60 here. And opposite the 30 was my 1. Remember we said those are called cofunctions. Remember the last thing on Thursday, we looked at your table. We noticed that the sine of 30, which is 1/2, is the same as the cosine of 60. We saw that these were cofunctions. We call these cofunctions. We're going to take another look at them today. The sine of 1, because don't the two angles in your right triangle add up to 90? Because you have a 90-degree angle and then the other two are complementary. So these are called cofunctions. We'll take another look at them today. Okay, so let's try your third angle. What was your third angle?
7 pi over 4.
Thank you. So how many times does 4 go into 180? 45. So we've got a 45-degree triangle. So we start with the one we know and love. 1, 1, radical 2. Now we just got to figure out where does this belong. So if this is my 0 and this is my pi, and I want to make this into fourths, what do I have to put on top? So I can cancel them out. 4. What is this guy going to be? 8 pi over 4. Good, because that'll cancel out the 2 pi. Now, as I come around, I pass the 4. Whoops, there's the 8. I stop short of the 8. There's my 7 pi over 4. I drop my triangle. This is my reference angle right in here that I need. This time around, they're both 45, so that really didn't matter, but my reference angle goes in between my bow tie, because all my bow tie goes like this. Now, I label my sides. 1, 1, radical 2. Bring this information out. In this quadrant, what is my x? Is my x positive or negative? Positive. Is my y positive or negative? Negative. And my r, always positive. From there, can we do all our functions? So the sine of 7 pi over 4, get used to these, y over r, negative 1 over radical 2. Cosine 7 pi over 4, x over r, 1 over radical 2. The major difference there is the negative sign. We didn't even have to think about it because we took it off your quadrants. And we said in quadrant 4, x was positive, y was negative. And my tangent, 7 pi over 4, says y over x. Well, if I put negative 1 over 1, I get negative 1. Okay? Is that good? Now, be careful on this guy. If I have an angle whose tangent is -1. Watch up here for a second, guys. Tangent is negative in quadrant 4, we just saw this, and also in quadrant 2. If I go like this, it could be my y is negative, and my x is positive. Oops, my y is negative, my x is positive. That puts me here in quadrant 4. It could be, if I say tangent is -1, it could be my x is negative and my y is positive. It could be really coming from down here, but we only put one negative in the front, right? In this case, I would be quadrant 2. So just be careful with your negative sign. Also, even when we work our functions, if we say -3/4, that negative could be the 3, it could be the 4. So you're going to have to play with that a little bit. Now the last guy that we had was beta equals pi. This is called the quadrant angle. There's 0, pi/2, pi, 3 pi/2, 2 pi. Now, the easiest way to work your quadrant angles, quadrantal angles we call them, is off your unit circle. Your unit circle has a radius of what? 1. So this position would be 1, 0. This position would be 0, 1. This position would be -1, 0. And this position would be 0, -1. And yes, you can find these on your calculator, but if I ask you to do them without a calculator, you have to find them like this. So we know this is an xy point, and we know on the unit circle, because our radius is 1, that r is not needed, so this is our cosine, this is our sine. This is our cosine, this is our sine. So when we're looking at pi, we say, okay, sine of pi. The sine of pi is its y value, 0. Cosine of pi is its x value, -1. And the tangent of pi is y/x, 0 over -1. What is 0 over -1? No. 0. Okay? When we take the cotangent of this guy and we make it x over y, then this guy is undefined. Okay? Where is tangent undefined? At what two values? No, just tangent. Where is tangent undefined? Like what angles? The other two. 90 and 270. No, I said tangent. He said cotangent. I said tangent. Yeah. But cotangent you would be right with, Misha. That would be the opposite. So are we feeling this a little bit better? Your special triangles, rotating them around your circle? Hopefully yes. Hopefully yes. So today, we're going to take a look at doing a few more of these things. All right, so sometimes we talk a reference angle. Now, when I wrote this last week, your reference angle falls, here's your circle, it opens up this way. Now, our reference angles fall, our triangles make a bow tie, our reference angles all fall, here, let me see if I can pick a different color here. Here's your reference angles in here. It's the angle that we make from the terminal side to the x-axis. From the terminal side to the x-axis. All in here. This is your reference angle. That's where we get your special right triangle from. And we place it in there. So if we're looking at 5 pi, remember this is your terminal side. I've had all different troubles with this board. It's doing it again. This is your terminal side. They open counterclockwise. A negative angle will open the opposite way. So if we're looking for 5 pi over 4, we start like this. We put this guy over 4. So this has to be 4 over 4. This has to be 8 pi over 4. We start here, and where would we find 5? What quadrant? 3? Guys, are we making here today? 5 pi over 4, but 1 past the 4, didn't it? 45 is the nicest one because isn't half of 90 45? So watch. This is 45, every half. So it goes 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Look what it reduced to. Pi over 2, 3 pi over 2, 2 pi, pi. So 45 is the nicest one because it's evenly right between those quadrants. So we say, okay, there's 5 pi over 4 down here. We took 4 and we divided it into 180. Our reference angle is 45 degrees. So to find its reference angle, we're just going to take that bottom number and divide it into 180. That's if it's a special triangle. If it's not a special triangle, then we have to use the degrees. Such as this guy. So this one says, what quadrant of 0, 180, 360? What quadrant would I start here and rotate around counterclockwise? Where will I terminate? What quadrant to have an angle of 203? 3. I'm right past the 180. So now, I say to myself, how far past the 180 did we go? 203 minus 180. I'm 23 degrees. My reference angle is 23 degrees. Do I have a special triangle for that? No. So that I'm going to have to do on my calculator. If I don't have a special triangle, then I'll do that on my calculator. But all our special angles, you will always see them say exact value, exact value. Okay? Now, coterminal angles. Let's talk about coterminal angles. These were great 2-point questions on your Regents. They wanted an angle that shares the same side, like a co-pilot, a co-worker. You share with them. So they want someone that shares that side. So while this angle, let's work this one. This angle was 203, and your whole circle is 360. Excuse me. So if I take this, thank you, and I say, what does it take for me to make a complete circle? I say 360 minus 203. Negative 157 to meet me here. If I wanted to go here, excuse me, I'm sorry. If I wanted to go here and pass this and come back around, aren't I that angle plus 360 degrees? So to do coterminal angles, we take the angle plus or minus 360 degrees. If we do it in radians, we have the angle plus or minus what? 2 pi. Good. 2 pi is the same as 360. So sometimes they will ask for a negative coterminal angle, sometimes a positive coterminal angle. And we saw that in Algebra 2 as well. These guys, again, reciprocals. Now, hardly we see reciprocals like this. This is the true reciprocal. But if your sine is y over r, your cosecant is going to be r over y. You're just going to turn that upside down. If you leave me a fraction of 1 over something, it's wrong because you can't leave a complex fraction. So you're going to reduce that down. So where your cosine is x over r, your secant is going to be r over x. Where your tangent is y over x, your cotangent is going to be x over y. It is its reciprocal, yes, and they go both ways. They go both ways. They write them as reciprocals because that's what it is, but we're going to do it as, just flip those over. Easiest way to get there. And one other thing we deal with a lot, and that is the Pythagorean identities. So your tangent is your y over x, and y is your sine on your unit circle, x is your cosine. Your cotangent is x over y. From these guys, we get to Pythagorean identities. Pythagorean theorem. What is Pythagorean theorem?
A squared plus b squared equals c squared.
Good. And this deals with what kind of a triangle? A right triangle. So say I'm here in quadrant 1, and I open up and get myself an angle, and I'm on the unit circle. So this point over here is my xy point somewhere. I don't care what angle it is. This is my value of x right here. This is my value of y right here. So I'm going to apply Pythagorean theorem to this triangle, just a generic triangle. X squared plus y squared equals 1. Now I'm on the unit circle. On the unit circle, which one is the x? The sine or the cosine? Cosine. So I'm going to replace my x with cosine. So since it's squared, I have to square it. My sine is my y, and since it's squared, I have to square it. There's my Pythagorean identity. It's Pythagorean theorem. That's all it is. It's your Pythagorean identity. An easy way to remember it. Just x squared plus y squared equals 1. Cosine squared plus sine squared equals 1. It doesn't matter if I say sine squared plus cosine squared. No, that's fine too. Now, you don't have to memorize these either. Because to get those, all I have to do, I only have 2 things, cosine and sine. I can divide everybody by cosine squared. Everybody by cosine squared. Cosine over cosine is 1. Sine over cosine is what? Tangent. And what's 1 over cosine? Secant. And since they're squared, I keep the squared. There's your second identity. How do you think I do the third identity? What's left here? What's the other word? Sine. So if I took your Pythagorean identity, God bless you. You have my sneeze. And I divide everybody by sine squared. This gives me cosine over sine. Oh, there's my cotangent. This gives me 1. And this is my cosecant. Isn't that your second identity? Your third actually, off of the second off of the Pythagorean one. So I don't have to memorize anything. It's a Pythagorean identity. I draw a triangle, x, y, and 1. I figure it out. And then I divide by sine or divide by cosine. Okay? Questions so far? Nope. Okay. All right. And we're going to take a look at finding other things besides your special right triangles and your unit circle. Sometimes we don't have a unit circle. Sometimes we don't have a special right triangle. But we can still find its other trig functions. So because we're superimposed on your xy axis, what quadrant does this point exist? 12, negative 5. 4. positive x, negative y. So 12, negative 5. That means my circle came around and terminated right here. So I drop a triangle up to the x-axis. I say this is x, this is y. I do 12 is my x, 5 is my y. I don't put my positives and negatives on my triangle. I put them down here later. So if you'd like to keep them on your triangle, you're more than welcome to. But my r, how do I find my hypotenuse of a right triangle?
Square.
Pythagorean's theorem. So I say r squared equals 12 squared plus 5 squared. So it's the square root of 169.
13.
Okay, this is a triple. This is one of your triples. From this, I don't know what this angle is. Doesn't matter to me, but can I find all 6 trig functions? The sine of this angle is y over r. I've got all my information. Negative 5 over 13. The cosine of this angle, x over r. 12 over 13. The tangent, y over x. Negative 5 over 12. Can I find the reciprocals by flipping them all over? Yeah. So it's okay that I'm not on a unit circle, and it's okay that I don't have a special right triangle. They gave me a point on my circle. It's a point on my circle. So from there, I use that as my x and y. I have to find my radius. Remember doing these? Okay. Questions at all? Okay. I'm just throwing some different things at you. Because we did your triangles. This guy. Sometimes they don't give me an xy axis at all. I have to find all 6 trig functions for this angle. Is this a special triangle? No, because where should my 2 be if it was? My hypotenuse. So, to find that, I have to do Pythagorean's theorem. Now remember, you can get radicals. You got the homework sheet, right? Okay. You can get radicals. This is 1 plus 4. Leave all your radicals in reduced format. You know, if it comes out to be radical 20, you have to reduce this guy down. Leave all your trig functions in reduced format. You know, reduce all your fractions. So now, you can find all your trig functions. If you want, for this is your reference angle, this is your side opposite, this is your side adjacent, this is your hypotenuse. Use SOHCAHTOA for this. Okay, because it's not on a triangle thing. Right, you could find those, right? We would find those, the sine of this angle, opposite over hypotenuse, and so forth. Cosine of this angle, adjacent over hypotenuse, and tangent, opposite over adjacent. They're all going to be positive because they don't exist on the coordinate grid. Okay? Now, same thing with this guy. If I give you an angle with one function, you have to find me all the remaining functions. So right now, I have to tell you what quadrant it's in. So we're going to put this in quadrant 1. Actually, I didn't put it on anything. So you're going to say cosine is either x over r, if you put this on a triangle, or adjacent over hypotenuse. So here's my adjacent, here's my hypotenuse. Be careful when you find the missing side, because this one is 7 squared, 5 squared plus b squared. Subtract it, and again, you have to reduce this. So 2 radical 6 is your b. and then find all your pieces. You're okay from there? Once we find them all? Oh, let me give you a little hint too. Say I gave you this triangle. And I said, this is 6, this is 10. You have to find me the missing part. So I do 10 squared equals 6 squared plus b squared. Subtract, and I get b is 8. Now watch. If I just do this as this is opposite, this is hypotenuse, this is adjacent. When I set this up, sine, opposite over hypotenuse, 6 over 10, I have to reduce that. Divide by 3, 3 over 5. Divide by 2, 3 over 5. If I set cosine up, adjacent over hypotenuse, 8 over 10, I have to reduce that. So here's a nice way to do this. Over here, reduce this first. What do all those, what's a factor that I could take out of all of them? 2, because it's a factor that I would cancel out here. So there's my 3, 4, 5 triangle. So just use 3, 4, 5. Reduce it in your information box, and then you don't have to keep reducing them every time you do it. Okay, we have one more, guys. One more example. This will go fast, if I can get this to move. And you had these on your regents as well. These were nice little 2-point questions. Okay, that one you can find. You can find this guy. This is in quadrant 1. If there's a piece missing, put it over 1. So in quadrant 1, this is your y over x. Y over x. What angle is this? 30, 60, 90. So now you can find all your parts. This guy, break one step at a time. What quadrant is cosine positive? Where the x is positive? 1 and 4. What quadrant is tangent negative? 2 and 4. Which one do they overlap in? 4. So there's my answer. Quadrant 4. Okay?